Let's go to page 239, and let's start with 343. Okay, so this one has two circles. This is point P, point O, and this is point A. So AP is 15, and you're looking for the radius. Okay, so if you to draw the triangle, the radius drawn to the point of tangency is perpendicular to the tangent. So this is perpendicular. So this is radius, this is radius, this is radius, because they're congruent circles. So if you notice that this is 2r, this is r, so this is twice its size, so this is your 30-60 spatial triangle. Okay. So the relationship between that is that the square root of 3r equal to 15. So divide by square root of 3, divide by square root of 3, they cancel out. And now you have square root of 3 on the bottom, so you get r equal to 15 over square root of 3. So to simplify that, multiply by square root of 3. So r equal to 15 square root of 3 over 3, and you reduce, so r equal to 5 square root of 3. Okay. Let's go to next one. Okay, so 344, you have a triangle, and from this triangle you form a square. So this is A, B, C, and this is right angle over here. So AB equal to 4, BC equal to 6, and you're looking for area of the square. Okay, so let's go and call this X. So if you get the Pythagorean theorem, so you got the A square plus the B square equal to C square. Well, C square, this is actually, well, this happened X times X, that's your area. So this is what you're looking for already. So X squared is your K. And so it would be 36 plus 16. And so K equal to 52. And that's it. Okay, let's go to 345. Okay, the 345, the picture is giving. No, 345 is a triangle ABC. Okay, so the picture is this way. So you can just a random triangle. And it gives you the arc as x plus 40 degrees, 2x plus 20 degrees, and 2x minus 20 degrees. Well, the arcs around a circle is 360, so if you add all three together, it should equal to 360. So x plus 40 plus 2x plus 20. So this is this one here, this is this one here, and the next one equal to 360. So complete circle is 360. So go and simplify. You get 5x plus 40 equal to 360 and minus 40. So you got 5x equal to 320. Divide by 5. Divide by 5. So x equal to 64 degrees. number 346. Okay, this is the one that's given. Okay. So you got circle. So you say A, B, C. Okay, so it says angle ABC equal to 30 degrees. So this is 30 degrees from the area of the ABC. And what else do we know? Okay, the circle of radius is 4. Okay, so if this is a right angle, then the hypotenuse would be the diameter. So the radius is 4. Okay, so this is the 8 over here. And now this is a 30-60 spatial triangle. So this would be half of the hypotenuse, so this would be a 4. And this would be square root of 3 times that, so this would be 4 square root of 3. Right? And after that, the area would be simple. It would be 1/2 base times height. So again, you have to realize that when this is a right angle, that means this arc is 180, right? Because this is half of the arc. And if this is 180, that means this is the diameter. Okay, and then you work it out, so K equal to 8 square root of 3. Okay, 347. Okay, a triangle is formed with those vertices. So first one is 0, 15. So it's A is 0, 15. B is at 0, 0. And C is at 10, 0. Okay, and then you want to find the coordinate of D, so that the area of the triangle ABD is equal to area of the DBC. So you want to find out the coordinate of this so that this will have equal area. Now, if you turn this triangle this way, okay, notice that this is the height. So this triangle have this height. This triangle have this height. So if they have the same height and have same area, their base must be same, right? So they have to be equal. So this is equal to that. That means this is the midpoint. Okay. So to find this midpoint, you just average the two. Okay. So it'd be 5 and 15 over 2. Right. You can you add, divide by 2, you add, divide by 2, and that's it. So that's your answer. Okay. Okay, let's go to next one. Okay, the 348, the picture is giving. So this is A, B, C, D, E. If AC equal to 20, so because this is the whole length, so I'm going to write it big out here. And CD is 12, BE equal to 3. And you're looking for area of the BCDE. So you're looking for this area right over here. Okay. Now, if you see this is your, this is a right triangle, so Pythagorean theorem. So this 12, this would be a 16 over here. Okay. If you don't see that, what you do is you do this. So 12, AD, and 20. Right. So 3 sides. You can factor out the 4. So you got 3, 5. So this would be a 4. Right. 3, 4, 5 triangle. So therefore, this would be a 16. Okay. Or you can just use a squared plus b squared to figure out this. Okay. Now, next thing you have to realize is that the small triangle and the big triangle, the scale factor is 1 to 4. This is 4 times as that. Okay, so this would be 4 times as that, so this would be a 5. And this would be 4 times that, so this would be 4. So again, here's your 3, 4, 5. And here's your 12, 16, 20. So this is 4 times as that. Okay, now to find the area, okay, there are different ways you can do this. The straightforward way would be use the big triangle minus a small triangle. So K equal to big triangle, so it would be 1/2 base times height. Okay, minus a small triangle would be 1/2 base times height. So K will equal to 96 minus 6. So K equal to 90. Okay, so this is one way of doing it. Another way to do it is by just going to figure out the area of the trapezoid. So if this is 4, this is 16, this would be a 12. Okay, so the trapezoid, you have to kind of turn it sideways this way. Okay, so the trapezoid, you find the average base. So 3 plus 12 divided by 2. So that would be your median. Okay, so that would be median. So like your median base times the height. Okay, so times the height. And so K will equal to, so 15 times 6 give you 90. So you get the same area. Okay, let's go to page 3. Let's go to page 240. And number 349. So you're looking for what are possible numbers of common external tangent of two congruent non-concentric circles in the same plane that can have. Okay. Okay, so the first situation is when they overlap. Now remember, they are congruent and they cannot overlap itself, right? Okay, so it means they have to kind of off somewhere. Okay, if you have this kind of situation, okay, you're going to get two common tangents. Okay, you're going to get one here, one here. So in this case, you got 2. Now, if you continue to move them out, if you have this situation, then you're going to get this common tangent here, and this one here, and you're going to get one right over here. So you're going to get 3 in this case. Now, if you go make them even more further apart, okay. So you're going to get one here, and then you're going to get one here, one here. So you're going to get 4. So your answer would be 2, 3, or 4. Okay. Now this is the case of two congruent non-concentric circles. Now if you have the two circles, they are not congruent. Okay. So this is just additional note. So let's say if you have two different sizes, you got one here, then at a different size, like this. Okay, in this case, you're going to have 1. So if your two circles are not the same size, and then in case you're going to get one common tangent. Okay, but for the problem that we have, both circles are congruent, so you cannot have one like this. They will overlap. They will coincide with each other. So that is problem disallowed by the problem itself. Okay, but just be aware, if the circles are different sizes, you have another possibility. Okay.